Unit 2 review from AP Classroom. Unit 2 is more now focused on understanding what a derivative is and how to find it and so on. So Unit 1 had to do with limits. Now we're starting to get more into derivatives and what that means and what does rate of change mean. And number 1, it says, what's the average rate of change? That's the AROC. So that's algebra from 0 to 10. So there is a formula for AROC. And the formula is from 0 to 10, it would be f at 10, subtract f at 0, divided by 10, take away 0. So y2 minus y1, x2 minus x1. So in this table of values, f at 10 is negative 20, f at 0 is 5, and then 10 take away 0, 0. That's it. Negative 25 over 10, reduce it down, and that's it. You have your answer. So that's before calculus, understanding the average rate of change. Number 2. I'm committed to try to get this video close to an hour as I can. Oh, my camera went down. Here we go, number 2. In number 2, you're given the graph of the derivative of that. So there's the graph of the derivative, and then you're given 3 things. It says, what must be true looking off the derivative graph? H at negative 1 equals h at 3. There is nothing to do with the actual function that must be true that I see. That h is continuous. The function is continuous at 1. So do you see how there's a value for the derivative all the way through? So if you have a value for the derivative, it must be continuous all the way through for there to be a value all the way through. There's no holes, no breaks. This is continuous, the derivative. So therefore, the function must be continuous. So 2 is good. Number 3, the graph has a vertical asymptote at x equals 1. Absolutely not, because if there was a discontinuity, there'd be no derivative here. So the only one that's true of 1, 2, and 3 that I see is number 2. Let me check my answer key, and that's it. So if the derivative is continuous, then the function is continuous. Number 3. Oh, the question's at the bottom of the page. In number 3, if the function is differentiable at that value a, which of the following could be false? Which one's not a good statement? So if you can take the derivative at a, so false, f is continuous at a. That's true. The limit as x approaches a of f at x exists. That could also be true. The limit could exist. Let me continue here. Which one could be false? So the limit would have to exist there if the derivative is there. That's true. The limit, and this is the slope formula, would that exist? Yes. That's the definition of a derivative. The derivative is defined. Yep. So which one might be false? The second derivative is defined. That's the only one in terms of the information given that could be false. So based on what's given, everything else is absolutely true. The only one that could be false is this one. We don't know. There could be a sharp corner on the first derivative, so it's continuous and exists, but the sharp corner means for the second derivative doesn't exist there. Number 4. The limit as h approaches 0. And again, this looks like the setup for a derivative, so be aware of that. So the limit as h approaches 0. Obviously, if I plug 0 in here, you can't evaluate it straight up. So instead, I want you to think of the formula for derivative. This is the idea of the formula for the derivative. So there's the original formula. This is the slope formula. The x is crossed out, so it's just h in the bottom. But this is the idea. As h approaches 0, what's the slope? So if I look here and look here, if you take out the h, the second part right here, e to the negative 1 in terms of what you see, that's what we're looking at for f at x. So what does that equal? It's the derivative So f at x is equal to e to the negative 1, or really e to the x in terms of negative 1. So e to the negative 1 is, we're looking at 1 over e to the x, where x is approaching negative 1. That's the same as this. That's what we're looking at when we look at the function. And x would be negative 1. The derivative of that is you copy it, and then the derivative of negative x is negative 1. So we're looking at negative 1 over e to the x. That's what we're looking for. Or negative 1 over e, I should say. There's no x there, is there? So when we're looking at it, that's what we're looking at. Right here. All right, number 5. Again, this is like the limit definition of a derivative. So get a sense of what we're looking at when we're doing it. So as it's approaching 0, right? Think of this again in terms of what is this limit definition in terms of it. You could also take the derivative too, by the way. So this limit is definitely indeterminate. If you plug in 0, it's 0 over 0. What would happen if I took the derivative and then did it again? So if I took the derivative, because that might be helpful, let's see what direction that goes. The derivative of sine is cosine. The derivative of this, pi over 3 plus h, is 1, so there's no hook there. The derivative of sine pi over 3 is just a number, it's 0. The derivative of h is 1, so you're dividing by 1. And there's your answer. So now we can just plug in 0 for h, evaluate it. This is L'Hopital's rule. We could likely have done that in the numerator too. Take the derivative of the top and bottom. Probably would have been easier. Anyways, know your unit circle. This is a 60 degree on the unit circle. What's the x coordinate there? And the answer is 1/2. Turn the page. It's nice to have L'Hopital's rule to be able to do indeterminate. So the answer is B. All right, number 6. All right, if it's indeterminate, I'm still going to use L'Hopital's rule. So plug in 0. Ln 4, take away ln 4 over indeterminate. So L'Hopital's rule, the derivative of ln is a fraction. 4 plus h is the denominator. The derivative of that is 1. Ln 4, the derivative is 0, and the derivative of h is 1. So there we go. Now plug in 0, and you get the answer 1/4. Now, isn't it nice to have L'Hopital's rule? So if it's indeterminate, we can do it. Number 7. Oh, the question again is at the bottom. What's the limit as h approaches 0 of this? If I plug in 0 for h, I get ln e, take away 1. Ln e is 1, take away 1. It's 0 over 0. It's indeterminate. We have L'Hopital's rule. During this unit, we didn't know L'Hopital's rule, but we know it now. So if it's indeterminate, you can then take the derivative of the numerator, the derivative of ln e plus h. That's e plus h in the denominator. The derivative of e is a number. It's 0. The derivative of h is 1. And then the derivative of negative 1 is 0. The derivative of h is 1. So the derivative all along there. And now plug in 0 for h and then solve it, and I get 1 over e, or it might be e to the negative 1. Turn the page. So look at number 7. Or let me look at the question again. So the limit is h approaches 0 of that. I get 1 over e, or e to the negative 1. And the answer is none of those. Let's see. So in there it says it is A where f at e equals that. So let me just go back here. So the limit of here is 1 over e for that. The derivative there, in terms of what they're looking for, I'm trying to look here. So the derivative at e, where f at x equals ln x. So is that what it's describing in terms of it? So if we're working backwards looking at this in part A, this is what it would look like. The limit as x approaches e that's one way to look at it. The other way to look at it if it's ln x, then it'd be ln x plus h subtract ln x. That's what it would look like, all over h. So that's also the basic definition of a derivative using limits. And that's exactly what I have right over here, because ln e is 1 in terms of as it approaches e, in terms of what's happening. All right, that one's so confusing. Anyways, I'm going to put it right here. It's asked in an awkward way in terms of it asks for the evaluation of a limit. So the evaluation of that limit is definitely 1 over e. That's what it's approaching. And then there's all these questions to do with derivatives at each one in terms of what it would be. So it's seeing the connection between limits and derivatives and what you have. So the derivative of ln x is 1 over x. At e, that would be 1 over e. That's the connection. So the derivative of ln x is 1 over x. Then you plug in e, and the answer is 1 over e, and that's what we got on this side. So that's the connection to what's happening working backwards. All right, number 8. You're given a piecewise. If f is the function defined above, then what's the derivative at -1? So first it has to be continuous. So at -1, that gives me +2. At -1, that gives me +2. So it is continuous. Then the derivative, I need to look at both pieces, because it has to be true from the left and from the right. So the derivative on top is 3. The derivative on the bottom is -2x. And then I plug in -1 again. So if I plug -1 in at the top and the bottom, to me the derivative does not exist. But let me just double check, because the left side does not agree with the right side. Yay! I like it when me and the answer key agree. So again, -1, the answer is always 3. -1 for x, they don't agree with what the right answer is when you plug in -1, so it doesn't exist. If f at x equals that, then what's the derivative? So this looks like the quotient rule. So let me do the quotient rule. The bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. So that's what I'm looking for. I might have to simplify it. So let me just look here quick. If you have to match, you might have to simplify the numerator, combine like terms, and do that. So let's do that. So they definitely combine like terms if you turn the page. So let's do that. See how quick we can do it. 2x times 3 is 6x. And then -3x times 2 is -6x. So they cross out. 3 times 3 is 9. Negative times a negative is 2 times 2, which is 4. It's positive, so I get 13 over 2x plus 3 squared. That answer is D. Number 10. If 2 plus the absolute value of x subtract 3 for all x, then the value of the derivative at x equals 3 is, well, when x equals 3, when I have an absolute value, I need to know what the graph looks like. And so think of this as hk, where if I go to positive 3 and positive 2, so positive 3, think of h and k, that this is exactly, and the slope is 1. This is what it looks like. And so the derivative when x equals 3, because of the sharp corner, or the right and the left don't agree on the slope, you would say it is non-existent there because it's right at a sharp corner. Number 11. In number 11, just making sure I got the answer right before I keep going. So in number 11, you're given a limit question, and I want to evaluate the limit. So if you evaluate by plugging in 0 for h, it will end up being indeterminate in terms of it. So I'm first going to evaluate the left side and then make it equal to 2. So I'm going to do L'Hopital's rule. The derivative of arc sine is 1 over the square root of 1 minus whatever's inside there squared. The derivative of arc sine A is 0, and of that is 1. So there is the formula, and the derivative of A plus H is 1. The derivative of A is a constant 0. Anyway, that's the setup. Now when you plug in 0, you get this answer. 1 over the square root of 1 minus A squared, and we're going to make that equal to 2. All right, I'm going to do the reciprocal to make it a little bit easier. I'm going to square both sides. I am going to subtract 1, which is 3, divide by negative 1. So let's see how this is going to work. So we squared it, 1 minus, subtract 3, divide, that's negative 3. So for this to equal 2, this would have to equal 1/2. Did I not do the reciprocal on the other side? So the reciprocal on both sides. Then square it. And then you subtract. In fact, I'm going to add a squared. So add a squared and subtract a quarter. Then square root. That's root 3 over 2. That's the value I'm looking for. So turn the page. And the answer is root 3 over 2. Number 10. Number 10. Number 12. What's the derivative of 2 to the x? Do you remember the formula? So for an exponential, you copy it, but because the base is not e, it needs a friend, which is ln 2. So which one shows the correct definition of that? And the answer, number 12, is C. Do you know your rules? Number 13. For f at x equals a times e to the negative ax, where a is greater than 0, a constant, then what's the derivative? So for this, the derivative of a exponential base e is you copy it to begin with, times what's the derivative of the exponent? So that's just a number. So negative ax, the derivative is negative a. So if I put it together, this is what I would expect as the answer. And I'll turn the page, and the answer is E. Number 14. Let f and g be differentiable functions. So g at x is greater than 0 for all of x. So it's always positive. F at 0 equals 1 if h at x equals f at x times g at x, and the derivative of that equals this, then what does f at x equal? Okay, so the derivative of h at x is the first times the derivative of the second plus the second times the derivative of the first, right? It says when you take the derivative, it's also equal to this. So we're going to make them equal to each other. And then it says, what does f at x equal in terms of that? So do you notice that the left side and the right side can eliminate? This is what I get. Let's see if I'm right. So they eliminate, and then to get f prime at x by itself, divide by g at x, and I get f prime at x equaling 0, because 0 divided by g at x is 0. Let's see if I'm right. Oh, they get the answer positive 1. Oh, I know what I did wrong. Let's try again. So f at x it says f at 0 equals 1. So if that's true, if f at 0 equals 1, so then that's equal to 1. F at 0 is 1, so that's just g prime at x. F at 0 is 1, so that's g prime at x. And the rest I don't know. So again, I'm going to subtract. I still get this. Divide, I still get the answer 0. Let me keep fighting through this. Make sure I read it correctly. So f at 0 equals 1. So that means h at 0 equals g at 0 if f at 0 equals 1. So if I plug in 0 here, so h at x equals g at x when x equals 0. So when x equals 0, h at x equals g at x, because when x equals 0, f at x is 1. All right. And my goal is to find f at x. So if I take out g at x and make it h at x, or one of these things, I can do this. And they give you that derivative. Maybe I should just not even worry about doing the product rule. Just go right from here. So f at 0 equals 1. So when x is 0, the derivatives also equal each other. So the correct answer here is 1. So I'm going backwards here in terms of it. Unfortunately, my answer key doesn't actually go step by step, so I'm going to think through it again. So f at 0 equals 1. H at x is this. So again, the derivative is the product rule. The first times the derivative of the second plus the second times the derivative of the first. My goal is not to find f prime at x. Maybe that's what I was looking at. So my goal is to find f at x in terms of it. So if I make them equal to each other, so in the question, h prime at x is f at x times g prime at x. So if I factor out a g at x, all right. So if I subtract these, so I have f at x times g prime at x. If I subtract it, then I get g at x times the derivative of x equals 0 if you're subtracting. My goal is to find what f at x is, however. All right. So if the answer is 0 and f at 0 equals 1, we're working backwards. That's the idea. So if the x value is 0 and f at 0 equals 1, then the function here must equal 1, a constant. So the derivative of that is 0. Working backwards. All right. I'm not going to get a headache over it. Number 15. Some of these are better questions than others as I went through them. Number 15. The graph of two differentiable functions, f and g, are shown above. Which of the following statements about p prime at -2 is true? So p at x equals this. So the derivative of that would be the first times the derivative of the second plus the second times the derivative of the first. P prime at -2, just plug in the values. Now, if it's just the function at -2, you can see. So at -2, the answer is negative. So at -2, the answer is negative. That's all we're going to get out of it. The derivative at -2 for g. So find where -2 is for g. The derivative there is 0. No, sorry. The derivative at -2 is positive because it's increasing there. The value of g at -2. So the value at g at -2 is a negative value here. And then the derivative at -2. So the derivative here is -2. The derivative here at -2. Oh, wait a second. So f at -2 is actually 0. I thought it was negative. I wasn't looking at the scale right. But the derivative is positive there. So if I put this together, 0 times a positive and a negative times a positive, that gives me a negative answer. So the derivative of p at -2 is a negative answer. That's what I get. So I get the answer to it to be A. Let's see if I'm right. Excellent. All right, let's look at number 16. Y equals x squared times sine 2x. What's the derivative? The derivative for sine is cosine, and it's a double hook. The derivative of 2x is 2. Plus the second times the derivative of the first, and there you go. So we got 2x squared cosine 2x, and we have 2x sine squared x. And then we're looking for the answer that matches. In the answer, they factored out 2x. So if you factor out a 2x, you have 1x cosine 2x, and then you just have plus sine squared x. Sine 2x, I mean. That's not squared, that's 2. So x cosine 2x plus sine 2x. That answer matches with E. Number 17. Do you know the quotient rule again? So the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. And then simplify it. So 6x subtract 6x, they eliminate. This is 4. This is negative 9, so I got negative 5 over 3x plus 2 squared, combining like terms. So I got the answer to be D. Let's see if I'm right. Next one, number 18. If y equals sine 3x, then what's the derivative? So the derivative for sine is cosine, and the derivative of 3x is 3, and there you go. So the answer to number 18 is 3 cosine 3x. Number 19. I'm going to go through these a little faster now. So the derivative of sine is cosine. The derivative at pi over 3 would be the x coordinate at pi over 3. That's a 60-degree reference angle. The x coordinate is 1/2, and you have the answer. Number 20. I still want to make that commitment for under an hour. So for number 20, I got to look at the question on the bottom of the page. I keep doing that. So what's the derivative of that? Now make sure you recognize that that's another way that we can write this as sine x squared all to the exponent 3. That's what it means. So first we handle the 3. 3 times 1 in front. And then subtract 1 to the exponent. Then the derivative of sine is cosine. And then the derivative of x squared is 2x. So you get all those hooks involved. 3 times 2x is 6x. And then it's sine squared x squared minus or times cosine x squared. So 6x sine squared x squared cosine x squared. Let's see. Find the one that matches it. Number 21. Can you take the derivative? My eyesight's like going, right? That's derivative at 4. So write it calculus friendly. X to the 1/2, 3x to the negative 1/2. We can do that. The derivative is 1/2 x to the negative 1/2, just the power rule. Negative 1/2 times 3, subtract 1 to the exponent. And now plug in 4. No calculator. Can you actually do the evaluation? 4 to the negative 1/2. The square root of 4 is 2, and negative means 1/2, the reciprocal. Here, the square root of 4 is 2, and 2 cubed would be 8, but the negative exponent makes it 1/8. And so this is 1/4 minus 3 over 16. Common denominators. That's now 4 take away 3. So I get 1 over 16. Number 22. Don't turn the page. It's right there at the bottom. So the derivative of that at x equals -1. So we're going to write this calculus friendly to begin with. So that's x to the -3. That's x to the -1. And then plus x squared. And then we're going to evaluate it at -1. So the derivative here, -3 to the -2. So multiply and subtract 1 to the exponent. Oops, this should be -4. Negative times a negative is plus. Subtract 1 to the exponent. And then that's 2x. And we're going to evaluate that at x equals -1. Now, the good thing is -1 to an even exponent is just +1. Same thing here to an even exponent. It doesn't matter what it is. It's just going to be 1. And then 2 times -1 is -2. So if I put this together, I get the answer -4. Let's hope. And so the answer is B. 23. In number 23, the graph of the function f of the figure above has a vertical tangent at 2, 0. That's right here. And horizontal tangents at 1, -1. So right here, there's a turning point. And 3, 1. Right here, there's a turning point. All right. So those are vertical and so on. So the question is, for what values of x from -2 to 4 is it not differentiable? Where can you not take the derivative? So you can't take the derivative at a vertical tangent. You can't take the derivative where it is not continuous. Everywhere else you can take the derivative from -2 to 4. So the value at 0 and at +2. Those are the only places you can't take the derivative. The other option would be +3, which is fine. You can take the derivative at a horizontal tangent. The answer is 0. 24. At number 24, let f be the function given. And what's the instantaneous rate of change? IROC. That's just derivative. So this should be fairly simple. So that's 3x squared minus 12x plus 8. Just the derivative using the power rule. What's the derivative at 3? And you get 9 times 3, 36. 8, that's 35. Take away 36. And I get the answer, -1. Number 25. You have a function that's defined that way, x over x plus 2. What points x, y in the graph have the property that the line tangent to f at x, y has a slope of 1/2? So derivative means slope. So the derivative we need to figure out first. So that's the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 1, and then the bottom squared. So if I combine like terms here, you get 2 over x plus 2 squared. We're going to make that equal to 1/2. And then we're going to take and solve for x. So we're going to cross multiply x plus squared times 1, 2 times 2. When you take the square root, the answer could be positive or -2. And then when you solve for x, you're going to subtract 2. So when you do that and subtract 2, this is what you end up with. So negative 2 plus 2 is 0, and negative 2 minus 2 is negative 4. So I see the points 0 and negative 4. So the only ones that have 0 and negative 4 is there. And I'm not even worried about the y values, because those are the only ones that show the x value 0 and the x value negative 4. Number 26. In the xy plane, you have a line x plus y equals k. K is a constant and is tangent to that graph. What's the value of k? The word tangent, calculus, is to take the derivative. So take the derivative of y. So we're just going to do the simple power rule. So that's going to be 2x plus 3. There's the derivative. That gives you the slope that we're looking for. So if I'm looking at this, if I rearrange it, the slope of this line, y equals negative x plus k, I get the slope to be negative 1 if that's the tangent line. That's what m is. So if that's the case, take the slope and make it equal to negative 1. To get x by itself, subtract 3. Divide by 2. I get x to be negative 2. So if x is negative 2, then you can come back here to find the y value. So if x is negative 2, then 4 plus 1, 5, take away 6, that's negative 1. So y is negative 1, x is negative 2. The equation for k is x plus y. So add these up, and I get k, when you add them up, to equal negative 3. Number 27. The figure above shows the graph of a function which has a vertical tangent at 4 and a horizontal tangent at 5. Which of the following statements is false? So there is no derivative at 4, and there's no derivative at 2 because it's not continuous, and there's no derivative at 7 because it's not continuous. So 2, 4, and 7, no derivative. Everywhere else there's a derivative. Which of the following is false? Make sure I get it. Not true. Here we go. Camera. F is, so 0. Sure again. 2, 4, and 7. Not differentiable. Just telling myself that. 2, 4, and 7. F is not differentiable at 2 because the graph is it. That's true. F is not differentiable at 4 because the graph has a vertical tangent, like it. F is not differentiable. It is not true. It is derivative at 5. And 7 because there's a removable discontinuity. Perfect. So the only one that's false is C because it is differentiable at 5. A horizontal tangent is differentiable. It's the vertical one that's not. Number 28. At number 28, which of the following statements about the function is true? Cannot be used to conclude that f is defined at x equals 1. So which of the following statements about the function, if true, cannot be used to conclude that the function is defined at x equals 1? So if it's continuous at 1, then that can be used. If it's differentiable, it's continuous, so it's true. The line tangent to the graph exists. That means it's differentiable. So that's true. That's another way to say it's differentiable. If it's differentiable, it must be continuous. So all of those. So the only one that cannot be used to show that it exists is the limit, because a limit can exist and there's no value there. There could be a hole, a removable discontinuity. All right, number 29. What's the value of the limit as x approaches 0? If I evaluate at 0, I get 0 over 0, which is indeterminate. I'm going to use L'Hopital's rule. The derivative of 2 to the x is 2 to the x with a partner, ln 2. The derivative of -1 is 0, and the derivative of x is 1. If I substitute 0 in for x, 2 to the 0 is 1, and that leaves me just with the answer ln 2. There's my answer. Done. Number 30. It's amazing when I'm motivated that I can actually get through these questions quickly. You can, of course, press pause and try them first. That's the best. Evaluate this limit as h approaches 0. So first evaluate. 8 to the 1/3 is 2. Take away 2. This is indeterminate. So we're going to use L'Hopital's rule here. The derivative of this, 8 plus h to the 1/3. You multiply 8 plus h to the 1/3. Oops, what am I doing? Try it again. Just use the power rule. I was thinking exponential. So that's 1/3 a plus h, and then subtract 1 to the exponent. The derivative of -2 is 0. The derivative of h is 1. So that's what I'm left with. Re-evaluate 1/3. Plug in 0 for h. And then if you can evaluate that, that's a -2/3, you get the answer. So let's see if we can do it. The cube root of 8 is 2. And 2 squared is 4. The negative exponent means do the reciprocal. So that answer is 1/12. Number 31. Let f be that function. What is the value of the derivative at 0? Let's go. The derivative for 3 sine x is 3 cosine x. The derivative of 8 e to the x is 8 e to the x. Those are my rules. At 0, plug it in. The value of cosine at 0 is 1. And then e to the 0 is 1, so that value is 8. So we put it all together, and the answer is 11. Number 32. For question number 32, what's the derivative of secant x? Well, the derivative of secant x is secant tangent. That's what I'm looking for, right? That's what the rule is, secant tangent. So which one is actually going to show that, and which one's wrong? So if the first direction is the reciprocal, 1 over cosine, that's fine. The derivative of this, of cosine, is negative sine. Secant is 1 over cosine. Tangent is sine over cosine. So this is really sine over cosine squared. So I don't like 1 over sine or -1 over sine. So I don't like a and b for the derivative. The derivative of this, notice how they only took the derivative of the denominator. If they're going to take the derivative here, they'd have to do the quotient rule, the way it looks. And so the quotient rule is described here. So which one is the correct quotient rule, which one's wrong? Just look at it carefully, and you can see one is subtracting and one is adding. So the correct quotient rule is this one that's subtracting, not the one that's adding. So the correct answer is C. Question number 33. In question number 33, the graph of f is shown above from A to B. the derivative of f exists for all of x except at 0. Right here, there's a sharp corner. For how many values of c from there does the limit of x at c equal that? Okay, so this is the derivative. This is the a rock, and this is I rock from a to b. So if I look in terms of the average value from a to b, this line, that slope, what other values would equal that slope? And it says that f at b is greater than f at a. So this is a line sloping up. But if I take that line as I go across, what other tangent could match it? So there's a spot here that could work, and there's a spot here that could work. So if I took that line, I could get the same slope using this. That same line could touch the graph here, and that same one could touch the line also here. So I get two places where a rock would equal I rock. Nowhere else could I draw a tangent line and it would have the same slope. So the answer I get is 2. Number 34. Same question. So for 34, you're given I rock equals a rock. So if you connect a to b, that's the slope we're looking for. So if we move along, where else could you get a tangent line that has the same direction? So right here could give me a tangent line with that. This right here could also give me a tangent line like that. This and this. I see 4 different places where that tangent line could match. So 34, the answer is D. Can you close the door, please? And you can stay in here. Number 35. I was a little worried it was you. 35 says to use a calculator. So let f be the function. F at x equals that. Of the following values of x, at which of the line tangent to the graph of f has the greatest slope? So the greatest slope would be the greatest number. I'm going to use my calculator and make it as easy as I can. So let's take out our calculator. To make it easy, I'm going to first evaluate and actually define it in my calculator. So I'm going to take my calculator and I'm going to take that function given, make sure it's in radians. I'm going to press, make sure this is all clear. All right, so press tab. I'm going to just type it in. So that's x to the 4th. That is plus 1/2 x cubed. That is minus 5x squared plus tangent x divided by 2. Double check. Did I type it in correctly? So that looks good. Press enter. Now we've defined it. I don't even care about the graph. Now we've defined it. I'm going to go back, and now I'm going to start calculating at each value that it's asking me to calculate. And whichever one gives me the greatest answer, that's the answer. So the first one, we're going to press derivative. So menu and calculus and derivative at a point. So it's x. The value we're first looking for is -2. And then all I type in is f1 at x. And it's all set up, and I'm going to look at that value. Now I'm going to go to the next one. So now it's the same question, derivative. So calculus, derivative at a point. Now we're looking at -1. Oops. Do that. That's x. Now we're looking at -1. And then f1 at x. And now the answer is positive 8. So that one's greater. So now we've got that. If you want to, we can do this and then change that to 0. That's 0.5. I'm almost done the video, I promise. Even the video people, I promise. And then one more time at positive 1. So of those, which one gave me the greatest derivative value? That would be the greatest slope. And the answer is that negative 1 gave me the greatest answer for the derivative, the biggest answer. So the answer there is negative 1. All right, we're going to try that again. So for 36, you get a calculator again. You have a function. It says, what's the value of the derivative at 1 with your calculator? So do you know how to use your calculator to do this? So let's do this together. So with your calculator, go Menu, go Calculus, and we're going to take the derivative at a value, which is at 1. Oops. Go back, go down. Then I'm going to plug in the function, not f1 at x. It's a different function. So it's cosine x subtract cosecant x. So there you have it, cosine x subtract cosecant x. And then what's the value of the derivative? And then look for the answer that matches it. So the answer to number 36 is C. To number 37. Let f be the function, given that. What's the derivative at negative 2? No calculator this time. But a pretty straightforward question for calculus. So the derivative here is 15x squared minus 3. The derivative at negative 2 would be 15 times negative 2 squared, subtract 3. Negative 2 squared is 4, and 15 times 4 is 60. So 60 take away 3 is 57. So our answer is right there. If it's a simple question on the exam, we have to do it in a really quick way because there'll be questions that will take longer to do. Number 38. In number 38, f at x equals ln x times cosine x. What's the derivative? That's the product rule. And the product rule is the first times the derivative of the second. Oops, I should say ln x times negative sine x plus the second times the derivative of the first. The derivative of ln x is 1 over x. So which one would match that I see? So ln x times negative sine x and then cosine x over x. So order doesn't matter. So it's negative ln x sine x and then cosine x over x. The answer is C. All right, let's look at question number 39. In question number 39, here, just let 1 second here. Are you okay? Yeah. Okay, I just need to finish this video for my students. And so you can be here quietly, or if you can't, you can go to another room, and then when I'm done, you can come back here and then we'll go from there, okay? Oh, good. So, number 39. In number 39, we have a table of values. So when x is 2, the function value is negative 3. The derivative is 1/2. The function value for g is negative 3, and the derivative at g is 2. The table above gives values for that differential functions from f and g at x equals 2. And it says h at x equals this. Find the derivative. Very popular type of question for the AP exam. Can you follow derivative rules generically? So the derivative of h is the quotient rule, which is the bottom times the derivative of the top. That is 4 times f prime at x. Subtract the top times the derivative of the bottom. That the derivative of g at x is g prime at x. And the derivative of 1 is 0, so it'd just be g prime at x. And then you take the bottom and you square it. So there's the derivative rule. Now we need to plug in 2 everywhere. So what's the derivative at 2. So g at 2, looking off that, that's negative 3 plus 1. The derivative at 2 for f is 1/2. I'm just going to go all the way across here using the table of values. F at 2 is negative 3. G prime, that's 2. And then g, the value is negative 3 plus 1 squared. So those are all the values from the table. So this is negative 2. Half of 4 is 2. This is 12 times 2, 24. This is negative 2 squared, which is 4. We're almost there. Negative 4 plus 24 is 20 divided by 4. So the answer is 5. There's the answer. And we're done. Number 40. In number 40, shown above is the graph of a differentiable equation along with the line tangent to the graph at 2. What is the value of the derivative at 2? That's just the value of the slope here. This is up 1 and to the right 2. That's 1/2. And there's your answer. The slope. Up 1 over 2. Number 41. Let f be a differentiable function, f1 at negative 2. The graph of the derivative of f, is shown. Which of the following statements is true about the line tangent at x equals 1? So the derivative at 1 is right here. The derivative at 1 is clearly 0. So the slope is 0, so A and B are wrong. If the slope is 0, what point does it pass through? And the answer is 1 and negative 2. That's what's given, so the answer is C. The slope is 0, and it passes through the point 1, negative 2. 42. The graph of f and g are shown above. H at x equals that, then what's the derivative? So first I have to do the derivative using the product rule. That is the first times the derivative of the second plus the second times the derivative of the first. Then we're going to plug in 6 and then look off the graph to get values at 6. So I plug in 6 and then I'm going to look off the graph. So looking off the function value for f at 6. So 1, 2, 3, 4, 5, 6. So the function value for f at 6 is 0. So I don't even care about the derivative because 0 times anything is 0. The function value for g at 6 is right here. Give me a moment. The derivative of f right there is the slope. That's down 1, 2, and to the right 1. So down 2 and to the right 1. So that's negative 2. Now, I want to find the value there that's in the middle of this line. What would that value be? And so in understanding that, I actually have to understand the equation of this line segment. It pretty close is to the middle. So if I was going to be quick about this, this is 2, 3, 4. So this looks like 3.5 to me. So negative 2 times 3.5, I get the answer negative 7. If I had to go quick, that's exactly what I would do. Estimated off the graph, that looks like 3.5. And there's no other answer close to that, so the answer must be negative 7. Number 43. In number 43, you're given two graphs. The graph of these piecewise functions f and g are shown above. If the function is defined as f at x times g at x, find the derivative. Okay, so again we need to do the product rule. So the product rule would be the first times the derivative of the second plus the second times the derivative of the first. We're going to plug in the value 2. and then find the different values at 2 only. So what's the function value f at 2? So go up on the graph and the function value is 4. What's the derivative of g at 2? That's the slope, up 1 over 1. What's the g value, the function value for g at 2? That answer is 5. And then what's the slope at 2 for f? Again, this one's up 2 and over 1, so that slope is 2. So that's 4 plus 10. That's 14. And there's your answer. In number 44, the table above gives values of differentiable functions, f and g, and their derivatives. So do you know the quotient rule? And then use the table of values. So the quotient rule is the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. So there is the rule. Now what happens at 0? We look at the table to give us value. So g at 0 is 2. The derivative of f at 0 is 4. F at 0 is 3. The derivative of g at 0 is that pi? It is pi. And then the denominator, the value of g at 0 is 2, and it is squared. So if I put that together, I get 8 subtract 3 pi over 2, or over 4, I mean. That might be 2 subtract 3/4 pi. We'll see. Eight subtract 3 pi over 4. So the answer is A. Number 45. Again, we're given a table. The average rate of change of g over from -3 to +3. How do we set up A rock is f at 3 subtract f at -3. And then in the denominator would be 3 subtract -3. So there's the setup. So the denominator is 6. Looking off the table, f at 3, or it's g, sorry. So it's g at 3, g at -3. So g at 3 is equal to -4. G at -3 is 12. So that's -16 over 6. That's -8 over 3. Or I can just look here, -4, take away 12, and there it is right there. It matches with B. All right, 46, same question. Average rate of change from -2 to +2. You should press pause and try it, then press play. So this is going to be g at 2 subtract g at -2, and then 2 subtract -2. Looking at the table of values, g at 2 is 5. G at -2 is -3. And then this is 4. So 5 subtract -3 over 4. So 5 subtract -3 over 4. So the answer matches with B. 47. What is the slope of the line tangent to this? So we have y equals, and the word tangent means derivative. So I'm going to take the derivative of that. That's going to be the quotient rule. That is the bottom times the derivative of the top. Don't forget the little hook. The derivative of -x is -1. Subtract the top times the derivative of the bottom, which is 1, and then the bottom squared. Then it said plug in 1 for x. So what's the derivative at 1? So 1 plus 1 is 2. That's -e to the -1 to the -1 all over 1 plus 1 is 2 squared, which is 4. 2 divided by 4 is 1/2. Negative e, so well, let's combine like terms first. So 2 subtract 1 is, or -2 subtract 1 is this. If I combine like terms, if I write that properly, it would be -3/4 but e to the negative 1 would be at the bottom. So it'd be negative 3/4 with e at the bottom. So that matches with B to do the algebra. Number 48. What is the slope? That means what's the derivative? So the derivative of ln, what you see is the denominator. The derivative is the numerator. So that simplifies to 1 over x. Plug in 4 for x, and you get the answer 1/4 is the slope there. Number 49, you get to use your calculator. You're given a function, and you're given g, and it said, what value of x do the graphs f and g have parallel tangent lines? So for that, we're going to do an equation. We're going to solve it. So here, let me show you how we're going to do. We're going to solve an equation. So menu, algebra, and we're going to solve an equation. And it's the derivative of both sides. So we're going to take the derivative. That's menu, calculus, derivative with respect to x. And then the first derivative is 3e to the exponent 2x. Move the cursor, equals, again, derivative. And the second one is 6x cubed. And then we're going to go comma x. And then solve it. So at what value, oops, try it again. And why would it give me an answer? So the derivative of that equaling the other derivative, comma x, and then this is the answer I got. So how do I interpret that? So where are the slopes equal to each other? So let's try it a different way then. So it doesn't feel like that's going to give me the right answer. So I'm going to go to the graph. I'm going to go actions, and I'm going to delete what I have. And then I'm going to type each one in again. So that's 3e to the 2x. Make sure I typed it in right. Sometimes if I 3e to the 2x and then 6x cubed. You know what, another way you could do it then? Fine. Take the derivative and do it that way. I can easily take the derivative of both and make them equal. So let's do it that way then. So we're going to solve this. The derivative of 3e to the 2x is 3e to the 2x times 2. So it's 6e to the 2x equals, and the derivative of 6x cubed is 18x squared. Oops, I didn't mean that. And then we're going to go comma x. And now let's see if we have an answer. So take the derivative first. I still get an awkward answer here. That's so sad. So either way, 6 times e to the 2x, that. All right, I guess we do have to graph it. So the first graph, again, is the derivative, which we just said was 6e to the 2x. Did I do the wrong e? No, I did the right e. All right. So 6e to the 2x. We're going to graph it. Oops. And then the second one is just 6x cubed. And the derivative, of course, is 18x squared. And then we're looking to see where they intersect. So if I press menu, and if I go to analyze, where they intersect is number 4. So I get the answer, -3, 9. 1 if I round. Negative 391. Finally, get an answer that matches. So we're trying to find where the derivatives are equal to each other, and then using our calculator, that's the answer I get. I don't know why analytically the calculator didn't want to answer it, but off the graph we could get an answer. So, number 50. So let f be the function, defined that way. Which of the following is an equation of line tangent to negative 1? So x is negative 1. The y value, plug in negative 1 for x, and I get negative 4 plus 5 plus 3 using negative 1. So that answer is 4. And then I need to know the slope. So I'm going to take the derivative. That's 12x squared minus 5. Again, use negative 1, and I get 12 take away 5, which is 7. So the slope is 7. So I'm looking for this equation. 7x plus 1. Oops. 7x plus 1 plus 4. It could also be 7x if you distribute plus 11. That could also be the answer. So let's see which one is that. And it matches with C. All right, number 51. You get to use your calculator. Let's hope I'm better here. It says, which of the following is an equation of the line tangent to this graph at the point where the derivative is equal to 1? So first of all, we're going to take the derivative and make it equal to 1. So we're going to come back here. So we're going to go solve. Let's hope we can do better here. So we're going to go solve. And I have x to the 4th, or the derivative. So we want to do the derivative. And we're doing the derivative of x to the 4th plus 2x squared equal to 1 comma x. So I get the x value to be 0.2367. So the slope is 1. So the slope is 1. The x value is 0.236. And then if I plug in to find the y value, I'm just going using that number, 0.236 to the 4th plus 2, 0.236 squared, 0.114 and now can I put it together? So to put it together, it's and then if you distribute and combine like terms, you're going to have to combine these together. So we're going to subtract 0.236, and I get negative 0.122. So if I subtract it, I get negative 0.122. So if you put it together, this is the answer you get. Y equals x minus 0.122. So that matches with D. All right, number 52. I don't know. What levels to what? Calculus?
How many levels are you doing?
Oh, I'm just doing 1 unit review of calculus. I know. All right, last one, I think. 52? No, there's 2 more. All right, let me finish. Here we go. An equation of the line tangent to that equation at that point is what? So I want an equation of a tangent line. So I need to know what these values are when asked about it. So I'm told already that x is 0 and y is 1. To find the slope, we take the derivative of what I see. So the derivative of x is 1. The derivative of cosine is negative sine. And then I plug in the value. So x is 0. So when I plug in 0, the value of sine at 0 is 0. So the slope is 1. So I get 1x. The slope is 1. 1x plus 1. That's the equation of the tangent line. And that matches with B. Last one. I'm going to do better next time and get under an hour. Okay. The function is given. What's the derivative at 1? Man, these are the nice easy ones. So the derivative at 7x is 7. The derivative of negative 3 is 0. The derivative of ln x is 1 over x. Plug in 1. 7 plus 1 divided by 1. And the answer is 8. And you have it. Done. All right. Mr. G Math over and out. I'm proud of you for doing your work and reviewing with me. Till next time.